Guys, dito ngayon ako sa shop namin dito, sa workshop namin dito sa Damam. Nagpapa-shoutout nga pala yung aking kaibigan na si Gilbert, kababata ko yun, seaman yun. So, ito yung separator para sa gas compressor. So, ngayon, i-recondition lahat to. So, nakikita nyo, ipapakita ko sa inyo yung picture nito before. Tinanggal lahat ng mga valve na may actuator. So, magkapatong siya. Dalawang unit siya. So, lahat yan, i-calibrate, i-recondition, tapos i-assemble uli. Tapos, pagdating sa site, i-calibrate uli, i-calibrate uli. So lahat yan, pati itong tank na to, i-calibrate namin yan. Nilinis na namin yan, pinasok na namin ng mga yung high pressure hose na 15,000 pressure na high pressure hose na water. Tapos yung mga paint, i-repaint uli namin yan. Pasok tayo sa loob ng workshop namin. Ito yung workshop. So guys, makikita sa inyo, ito yung complete valve workshop namin. So as you can see, ito yung valve na may actuator. Good morning! Boss, this actuator already testing?
Yeah.
But how much the voltage of this one?
24 volt.
24 volts? And how much the opening pressure?
Opening pressure around 3.5.
Okay. We have already power supply there. We already
No, I have the.
No, we both.
Hmm?
We buy for power supply because we done also the other actuator. So you can use that one.
Which one? 24 volt.
Yeah, 24 volts.
I checked.
This is our best electrician, no? Your electrician for the separator. It's for my wife.
Ah.
Good day. Good morning. All okay?
Okay.
Say hello to Gab.
Yes.
It's New Year, huh? Still working, huh?
Yes, alright.
So, as you can see, this all we will recondition. This one we have damage. We need to replace it. That's why we separate it.
the process system. It manipulates the stream of produced fluid to take advantage of the density differences that exist between gas, oil, and water, and that causes these phases to separate. Because of the relative densities of gas and liquid, their separation is quick, usually a few seconds. Some liquid may remain for a time in the gas in a fine mist. Densities of oil and water, however, are closer and can take a few minutes to separate. Inside the separator there are several pieces of equipment to help the process. The test separator is mainly composed of effluent inlet, deflector plate. A flow breaker or deflector plate is placed in front of the inlet. The gas flows round the breaker and the liquid falls to the bottom of the vessel. Coalescing plate. Dixon or coalescing plates arranged in an inverted V-shaped group small droplets of oil into bigger drops which under the action of gravity trickle down into the liquid. Gas leaving the coalescing plates may not yet be dry. Foam breaker. A wire mesh foam breaker prevents waves of foam passing along the separator and being carried away with the gas. Mist extractor. Before leaving the separator, the gas will pass through a mist extractor composed of a mass of wire mesh. It is designed to stop tiny oil droplets down to 10 microns from leaving the separator out of the gas line. Weir. If the level of the water is controlled, a weir placed in the bottom of the vessel will allow only oil to overflow and spill into the oil compartment. Vortex breaker. Oil and water pass through vortex breakers on the outlets to prevent gas flowing out these lines. Oil level controller. When the oil level changes, according to the principle of Archimedes, the plunger will be buoyed up by a force equal to the weight of the displaced fluid. Water level controller. The controller can be adjusted for throttling action if there is a steady flow of water, or for snap action if the water is to be drained at one time. Oil, water, and gas outlets. Pressure safety valves. Manhole to service the separator during its maintenance. The separator's vessel capacity for each phase depends on the current conditions of pressure and temperature and effluent properties such as viscosities and densities of the liquids, which are a function of the amount of dissolved gas vessel operating. Liquid level. Vessel internals. Required liquid-gas separator efficiency in terms of size of liquid droplet to be separated from the gas phase. The separator's control system includes gas line control, wizard, 1 3-inch PCV, pressure control valve, fail-safe open to release vessel pressure if air supply is lost, oil line control, level control, 1 1-inch and 1 2-inch LCV, liquid control valve, fail-safe close to retain oil, minimize pollution if air supply is lost, water line control, level control, 1 2-inch LCV, liquid control valve, fail-safe close to retain liquid, minimize pollution if air supply is lost. Pressure control. When gas line pressure drops, Borton tube contracts, closing nozzle, relay switches allowing pressure build up to close valve. As gas line pressure rises, Borton tube expands, opening relay and releasing pressure from valve allowing it to open. The proportional band valve reduces the response time of the valve to act as a damper and prevent oscillation of the valve, and therefore, reducing pressure oscillation in the separator valve.